Hello and welcome to my tutorial video. In this video, I'm going to be teaching you the column method. So let's start with this first question I have written up here, which is 62 minus 31. So you can say 62 minus 31 or 62 take away 31. But what's important to establish when looking at the column method is also we have to look at the place value, that this is the tens, these are ones, tens, and ones. And when setting up for the column method, it's important that the first number always goes on top and the second number always goes on bottom. So let's start by identifying what this really means. So I'm just going to do a little table, set up our hundreds, our tens, and our ones. And be patient with me here. I'm using this stylus software for the first time. So we don't have any hundreds tiles. We do have 6 tens tiles. And if we have tiles in class, it's good to show these to students to use. And we have 2 ones tiles. So when we're setting it up in the column method, we write down 62, take away, and we make sure that we line up our numbers, 31. In our visual representation, we won't be drawing this 31 because we're taking it away from our 62. So I look at my ones column and I know I need to take away 1, so 2, take away 1. So I can do it visually. I can take 1 away. So 2, take away 1. This is a 1. And from 6 tens, I still have 6 tens. I have to take away 3 tens. 1, 2, 3. That leaves me with 3. 6, take away 3 is 3. It's in fact 60, take away 30 is 30. So our answer is 31. And let's look at the next problem. I'm just going to move this up a little bit. The second problem we're going to look at is 432, take away 111. So again, we can follow our columns method. Let's just do our columns method and see if it works using a visual representation. So we said we line up our ones, our tens, and our hundreds, and we work from the ones column, starting to take away. So 2, take away 1 is 1. 3, take away 1 is 2. 4, take away 1 is 3. Now let's verify this with a visual representation. We have hundreds, tens, and ones column. So we have 400 tiles. 3 10 tiles. And 2 1 tiles. So again, we don't write down the second number or draw the second number because we're taking it away. So we start with our ones and we take away only 1. When we move on to our tens, we take away 1 again from the tens. And then we move on to our hundreds, which was 400, 2, 3, 4, and we take away 100. So then we check how many are left at the end. We have 1 in the ones, 2 in the tens, and 3. So we've got the same answer. So let's move on to our third example. Third example, we're going to try to do it without the visual representation. We're going to try to do it on our own. So again, we set it up. So our third number is going to be 679 minus 75. So what's important to note here is I had to line up my ones, my tens, and my hundreds. There's no 100 in the second number, so I left that spot blank. And my tens lined up and my ones lined up. So which side do we start from? Always the one side. 9, take away 5 4. 7, take away 7 is 0. So I have to make sure I write down that spot, that's 0, because I'm telling us, I'm representing that there is no 10s left. And 6 take away 0 is 6. So our answer is 604. So in all these scenarios, the top number values were bigger than the lower number values, but that's not always the case. So let's move on to the concept of, of borrowing or compensating. So I will draw this first one out. So it's going to be number 4. So we have 43, take away 14. So 43, take away 14. So we're going to do our table again. The hundreds, tens, and ones. Because the concept of borrowing is easily visualized when we see it visually. So we look at our first number, and that's the ones we draw visually, and we have no hundreds. We do have 4 tens. And we have 3 ones. So now we start taking away, and we always start with our ones. So I have to take away 4 ones. 1, 2, 3. Uh-oh. I don't have enough ones. What do I do? If I don't have enough ones, I can look at this and say, hey, I can take this 10 and break it up into 10 ones. Because 1 10-tile is the equivalent of 10 ones. So I've gotten rid of this. I've moved them over, and I need to take away 1 more one. So how many ones do I have left? 9. Now in terms of the tens, I needed to take away 1. So I have to take away 1 more. And what do I have left? 2. So let's see if we can do the same thing we visually represented it here over in the column method. So in the column method, when I say 3, take away 4, I'm left with the same uh-oh moment. But I'm going to do the same thing. I know that this 4 actually represents 40. So I can rewrite this 40 as 30 plus 10. So I will take away the 10, leave the 30 here, and put the 10 right beside my ones, just like I did here. I took away a 10, and I converted it into 10 units in my ones column. So if I look at my ones column, I had 10 and 3, so I had 13 ones. And I have the same thing over here, 13 ones. So now I say 13 minus 4, easy. We can say that that's 9. Now when I look over at the tens columns, I have 3 or 30 left. Just like when we started here, we had 30 left. Sorry, we had 30 left. It's like a little happy face. And we took away an additional 10. So we're going to take 3, take away 1, that's 2. See, we got to the same answer. So let's try another one with borrowing. So we'll call this number 5. So we have 82 minus 76. So let's try to do it visually again, because it always helps to see hundreds and ones. So we have 8, and 2 ones. So I need to take away. So I start with my ones. I need to take away 6 from the 2. So again, I say, oh no, I can't do it. So I take one of these 10s and I convert it over to 10 individuals. Now I take away my 6. 1, 2, 3, 4, 5, 6. And I see what's remaining. 1, 2, 3, 4, 5, 6. And then I go to my hundreds. I'm sorry, this should be 10s. I guess I decided to make a 2-prong instead of a 3-prong table because we have no hundreds. So I look at my 10s and I say I need to take away 7 10s. So 1, 2, 3, 4, 5, 6, 7. That means I have no 10s left over. And let's see if that holds true with the question that we did over here using our columns method. So again, in the same format, I look 2 minus 6. Oh no, it's 2 is smaller than 6, so that means I need to borrow. So I go from the 8 or from the 80, I take away 10 individual units and leave 7 behind for 70. So now 12 minus 6 is 6. And in my 10s, I have 7 minus 7, which is 0. Which again, we don't usually write down the 0 if it's the only number left over. If there was still some hundreds, we would write down that 0 to have a placeholder. But when there's no other numbers, you can just leave the answer as 6. So let's try one more. This time we're going to try to do it without any visual representation. Sorry. So now we're on number 6. So number 6 will have 3,314 minus 292. So what's important to note here is how I wrote it down. I kept my ones under my ones, my 10s under my 10s, my hundreds under my hundreds, and my thousands under their thousands. And because there was no 1,000, I have to hold that spot. So we start subtracting, always with the ones. So we're starting with our ones. 4 minus 2 is 2. Now we move over to our 10s. 1 minus 9, can I do that? Can I take away 9 units from 1? No, so I need to borrow from my hundreds. So I convert this to 200, and I bring over the 100 to the tens column. So I have 11 minus 9 is 2. Now I look at my hundreds column. I have 2 minus 2. I can do that. That's just a 0. And that leaves 3,000 to put down. My answer is 3,022.